In order to find the value of the limit, we first need to recognize that we're dealing with the limit of a function f of x equals x to the fourth minus 81 over 2x squared minus 3x minus 9. Now we'd like to use direct substitution to solve this limit, but we can only do that if the function is continuous at the value that the limit is approaching. Now the only way that that's not going to happen is if we substitute 3 into the denominator and we end up getting 0. That means we'd be dividing by 0 and we wouldn't have a defined function. And unfortunately that's the case here, so this function as it stands is not continuous at x equals 3 and we can't use direct substitution. However, if we factor the numerator and the denominator, we can come up with an abridged version of this function which might allow us to plug in 3. Factoring the numerator will give us x squared plus 9 times x squared minus 9. Factoring the denominator will give us 2x plus 3 times x minus 3. We can take the numerator one step further. We'll have x squared plus 9, and then that times x plus 3 times x minus 3. And the denominator is already as factored as we can get it. Again, 2x plus 3 and x minus 3. We can then cancel out the x minus 3's from the numerator and the denominator, and we now have this abridged function. X squared plus 9 times x plus 3, and 2x plus 3 in the denominator. Now we can look at the limit as this function approaches 3. Now we went through all that trouble to get this function because this function is defined at x equals 3. We can plug 3 into the denominator and not end up dividing by 0. So we can use direct substitution with this function to determine the value of our limit. So if we plug 3 in for x and work out that math, we're going to end up with 18 times 6 in the numerator and 9 in the denominator. And if we clean that up, we'll get our final answer, which is that the value of the limit is 12.